There are rare moments when the universe seems to hold its breath. The sun, steady and eternal, begins to dim. Shadows sharpen. The air cools. Birds fall silent as if evening has arrived too soon. Across the land, people pause, not because they were told to, but because something ancient stirs within them. An eclipse is not announced by sound or motion. It arrives quietly, unfolding above our heads, turning the familiar sky into something unsettling and extraordinary. For a brief window of time, the great order of the heavens appears to falter. Light yields to darkness. Day bends toward night. For thousands of years, this sudden transformation filled humanity with awe and fear. Kings trembled, priests prayed, armies stopped mid-battle. To early civilizations, the disappearance of the sun or the darkening of the moon was no coincidence. It was a message, a warning, or a sign from powers beyond human reach. Even today, armed with equations and satellites, eclipses still command silence. Crowds gather, voices fade, cameras lower. In those fleeting minutes, science explains how, but not fully why, the moment feels so profound. Perhaps it is because an eclipse reminds us of our place in the cosmos. We live on a moving world, circling a star accompanied by a silent companion, the moon, whose path occasionally aligns with astonishing precision. When the sky goes silent, we are reminded that the universe is vast, indifferent, and yet capable of breathtaking beauty. And for a moment, humanity stands united beneath a shadow that has crossed every generation before us. At its core, an eclipse is an act of alignment, a celestial shadow cast with extraordinary precision. An eclipse occurs when one astronomical body moves into the shadow of another, temporarily blocking light from the sun. From Earth, eclipses involve a delicate interaction between three familiar worlds: the sun, the Earth, and the moon. Though simple in definition, the result is one of the most dramatic phenomena visible from our planet. There are two primary types of eclipses: solar eclipses and lunar eclipses. A solar eclipse takes place when the moon passes directly between the Earth and the sun. As it does, the moon's shadow falls upon Earth's surface. In certain regions, the sun may be partially obscured. In rare and extraordinary moments, it can be completely covered, plunging daytime into an eerie twilight. A lunar eclipse, by contrast, occurs when Earth moves between the sun and the moon. In this alignment, Earth casts its shadow onto the moon. Rather than disappearing, the moon often glows in shades of deep red and copper, a result of sunlight filtering through Earth's atmosphere. What makes eclipses so remarkable is not just the alignment, but the scale. The sun is nearly 400 times larger than the moon, yet also about 400 times farther away. From Earth's perspective, they appear almost the same size in the sky. This cosmic coincidence allows the moon to perfectly cover the sun, creating total solar eclipses, an outcome that does not occur on most planets. Eclipses do not happen every month because the moon's orbit is slightly tilted relative to Earth's path around the sun. Only when these paths intersect at precise points does an eclipse occur. In this way, eclipses reveal the universe as a vast clockwork, where gravity, motion, and distance work together to produce moments of rare and haunting beauty. Eclipses are not accidents of the sky. They are the result of motion governed by gravity, unfolding with mathematical precision across immense distances. The Earth travels around the sun once every year, held in its path by the sun's gravity. At the same time, the moon orbits the Earth roughly every 27 days. These motions are constant, predictable, and remarkably stable. Yet eclipses do not occur every month, and this is where celestial geometry reveals its subtlety. The moon's orbit is tilted by about 5 degrees relative to Earth's orbital plane around the sun, known as the ecliptic. Because of this tilt, the moon usually passes slightly above or below the sun from Earth's perspective, preventing an eclipse. Only when the moon crosses the ecliptic at specific points, called nodes, can an eclipse occur. When the sun, earth, and moon align near these nodes, the stage is set for a shadow to fall. These alignments happen during periods known as eclipse seasons, which occur approximately every 6 months. During each season, at least one solar eclipse and one lunar eclipse may take place. The timing and nature of these eclipses depend on the moon's distance from Earth and the exact geometry of the alignment. In a solar eclipse, the moon casts 2 distinct shadows. The umbra is the central, darkest part, where the sun is completely blocked. Anyone standing within this narrow path experiences totality, a moment when the sun vanishes and the sky darkens dramatically. Surrounding the umbra is the penumbra, where only part of the sun is obscured, producing a partial eclipse. A third shadow region, known as the antumbra, appears when the moon is farther from Earth in its slightly elliptical orbit. In this case, the moon does not fully cover the sun, creating a glowing ring of light. Lunar eclipses operate on the same principles but on a grander scale. Earth's shadow is much larger than the moon, allowing lunar eclipses to last far longer than solar ones. The moon passes through Earth's penumbra and umbra, gradually darkening as it moves deeper into shadow. The reddish color often seen during total lunar eclipses is caused by Earth's atmosphere. As sunlight passes through the atmosphere, shorter blue wavelengths scatter away, while longer red wavelengths bend into the shadow and illuminate the moon. In essence, every sunset and sunrise on Earth is projected onto the lunar surface at once. Eclipses are moments when gravity, distance, and motion align with near-perfect balance. They are proof that the universe, vast and chaotic as it may seem, can produce moments of astonishing order. Not all eclipses unfold in the same way. Each type reveals a different relationship between light, shadow, and motion, offering unique experiences to those who witness them. The most dramatic is the total solar eclipse. During this rare event, the moon completely covers the sun, revealing the sun's corona, a faint, ethereal halo of superheated plasma normally hidden by intense light. Day turns to night for a few precious minutes. Stars appear. Temperatures drop. The natural world reacts as if dusk has arrived unexpectedly. More common is the partial solar eclipse, in which the moon covers only a portion of the sun. The sky dims slightly, and crescent-shaped sunlight filters through leaves and small openings, casting strange patterns on the ground. Without proper eye protection, however, these eclipses can be dangerous to observe. An annular solar eclipse occurs when the moon is near the farthest point in its orbit from Earth. Appearing smaller in the sky, it cannot fully block the sun. Instead, a brilliant ring of fire surrounds the moon, creating one of the most visually striking forms of eclipse. Even rarer is the hybrid solar eclipse, which shifts between annular and total depending on the viewer's location on Earth. These eclipses are brief and uncommon, highlighting the fine margins within which celestial alignment operates. Lunar eclipses, visible from anywhere on Earth where the moon is above the horizon, offer a different kind of spectacle. A total lunar eclipse bathes the moon in deep reds and browns, earning it the name blood moon. Unlike solar eclipses, lunar eclipses are safe to observe with the naked eye and can last for several hours. A partial lunar eclipse occurs when only part of the moon enters Earth's umbral shadow, creating a darkened curve that slowly moves across the lunar surface. The most subtle of all is the penumbral lunar eclipse, where the moon passes only through Earth's outer shadow. The dimming is faint, often unnoticed by casual observers, yet scientifically precise. Each type of eclipse represents a variation in distance, angle, and timing. A reminder that even the smallest changes in celestial geometry can produce vastly different experiences in the sky. Long before eclipses were understood as predictable celestial events, they were experienced as disruptions to the natural order, moments when the sky itself seemed to break its own rules. The earliest known records of eclipses appear on clay tablets in ancient Mesopotamia, where Babylonian astronomers carefully documented the movements of the sun and moon. To them, eclipses were not random acts of the heavens, but powerful omens, often interpreted as warnings directed at kings. A darkened sun could signal political upheaval, famine, or the fall of a ruler. In some cases, a temporary substitute king was appointed during an eclipse to protect the true monarch from cosmic harm. In ancient China, eclipses were seen as battles between celestial forces. Records dating back more than 3,000 years describe solar eclipses as a dragon devouring the sun. Court astronomers were responsible for predicting these events, and failure to do so could result in severe punishment. Drums, gongs, and arrows were used to scare the dragon away, restoring balance to the sky. Across the ancient Mediterranean, eclipses inspired both fear and curiosity. In Greece, early philosophers began to seek natural explanations. In 585 BCE, a solar eclipse reportedly predicted by Thales of Miletus occurred during a battle between the Lydians and Medes. The sudden darkness was so unsettling that both sides laid down their weapons, interpreting the event as a sign from the gods to end the conflict. This moment marked one of the earliest intersections between celestial prediction and human history. In the Americas, the Maya developed one of the most advanced eclipse tracking systems of the ancient world. Using careful observation and mathematical cycles, they recorded eclipses in codices and calendars, associating them with divine tests and cosmic balance. Their understanding allowed them to anticipate eclipses with remarkable accuracy, reinforcing the authority of priestly astronomers. Even without modern science, ancient observers recognized patterns. Over generations, eclipse knowledge was passed down through oral traditions, inscriptions, and sacred texts. These records represent humanity's earliest attempts to impose meaning and order on the unpredictable sky, a foundation upon which modern astronomy would later be built. Eclipses have always existed at the boundary between fear and fascination, where observation becomes belief and shadow becomes symbol. In Hindu cosmology, eclipses are explained through the myth of Rahu and Ketu, celestial beings born from deception and cosmic conflict. According to legend, Rahu, a severed demon head, pursues the sun and moon in eternal vengeance for being exposed. When he catches them, an eclipse occurs. Ritual purification, fasting, and prayer often accompany eclipses, reflecting the belief that these moments disrupt spiritual balance. Norse mythology tells a similar story. Wolves named Skuld and Hati chase the sun and moon across the sky. An eclipse marks the terrifying moment when one of the wolves nearly succeeds, foreshadowing the eventual destruction of the cosmos at Ragnarok. The sky's darkening was both a warning and a prophecy. In ancient Egypt, eclipses symbolized the struggle between Ma'at, the principle of order, and Isfet, the force of chaos. The temporary loss of light was seen as chaos gaining ground, requiring rituals to restore harmony between the earthly and divine realms. Indigenous cultures across the Americas viewed eclipses as moments when the veil between worlds thinned. Some believed that animals or spirits temporarily claimed the sun or moon, while others saw eclipses as opportunities for renewal, introspection, and communal prayer. In Islamic tradition, eclipses are understood not as omens, but as signs of divine power and order. Special prayers, known as Salat al-Kusuf and Salat al-Khusuf, are performed during solar and lunar eclipses, emphasizing humility and reflection rather than fear. Across cultures, eclipses inspired caution. Pregnant women were warned to stay indoors. Travelers delayed journeys. Leaders sought divine guidance. Yet alongside fear, eclipses also fostered unity. Entire communities gathered to witness the sky's transformation, sharing awe in a collective experience beyond everyday life. Even as scientific explanations emerged, the emotional weight of eclipses endured. They continued to symbolize change, impermanence, and the fragile balance of existence. In every culture, eclipses ask the same timeless question. When the heavens change, how should humanity respond? Throughout history, certain eclipses have done more than darken the sky. They have altered the course of human understanding and decision-making. One of the earliest recorded eclipses to influence history occurred in 585 BCE, during a battle between the Lydians and the Medes in Anatolia. As the armies clashed, the sun suddenly disappeared. Interpreting the darkness as a divine command to stop fighting, both sides laid down their weapons and negotiated peace. According to ancient historians, the eclipse had been predicted by the Greek philosopher Thales of Miletus, marking one of the first times celestial knowledge directly shaped human events. In 1291 BCE, a solar eclipse recorded in ancient Egyptian inscriptions may align with descriptions of cosmic signs found in later biblical texts. While interpretations vary, the event illustrates how eclipses were woven into religious narratives and collective memory. Centuries later, eclipses became tools for scientific discovery. In 1715, British astronomer Edmund Halley accurately predicted a total solar eclipse visible over England. His public announcement helped build trust in astronomy as a predictive science, transforming eclipses from omens into measurable phenomena. Perhaps the most influential eclipse in modern science occurred on May 29, 1919. During a total solar eclipse, astronomer Sir Arthur Eddington led expeditions to observe stars near the sun's edge. The results confirmed that gravity bends light, as predicted by Albert Einstein's theory of general relativity. This single eclipse reshaped physics and forever changed humanity's understanding of space and time. In more recent history, eclipses have united millions. The 2017 total solar eclipse across the United States drew massive crowds and global attention. For a few minutes, cities fell silent as people shared a collective encounter with cosmic alignment, an echo of ancient awe in a modern world. Each of these moments reveals a profound truth. Eclipses are not just events in the sky. They are catalysts, capable of ending wars, advancing science, and reminding humanity of its shared place beneath the cosmos. In the modern age, eclipses have become invaluable scientific laboratories, offering rare opportunities to observe phenomena otherwise hidden by the sun's brilliance. During total solar eclipses, scientists study the solar corona, the sun's outer atmosphere, whose structure and behavior remain only partially understood. The corona plays a critical role in generating solar winds and space weather, which can affect satellites, power grids, and communication systems on Earth. Advanced instruments, including high-speed cameras, spectrometers, and coronagraphs, are deployed across the eclipse path to capture data within minutes. Ground-based observations are often combined with satellite data from space agencies, creating a global scientific effort coordinated down to the second. Lunar eclipses also offer insight into Earth's atmosphere. By analyzing the color and brightness of the eclipsed moon, researchers can study atmospheric composition, pollution levels, and even the effects of volcanic eruptions. In this way, eclipses serve as mirrors, reflecting the condition of our own planet. Modern astronomy has also made eclipse prediction incredibly precise. Using advanced computational models, scientists can calculate eclipse paths thousands of years into the past and future. These calculations help verify historical records and refine our understanding of Earth's rotational changes over time. Yet despite all this precision, eclipses retain an element of unpredictability. Cloud cover, atmospheric distortion, and human perception still shape the experience. In the age of satellites and simulations, eclipses remain moments when the universe reveals itself most clearly, reminding scientists and spectators alike that some of the greatest discoveries come from simply looking up at the sky. Despite centuries of scientific progress, eclipses continue to reach places that knowledge alone cannot. When the sky darkens in the middle of the day, something ancient awakens within us. The rational mind understands the mechanics, yet the body reacts instinctively. Heartbeats quicken, conversations fade, eyes lift upward in shared anticipation. For a brief moment, the modern world loosens its grip. Fear once dominated humanity's response to eclipses. They were warnings of collapse, punishment, or divine anger. Even today, traces of that primal unease remain, not as terror, but as reverence. The sun is the source of life, and watching it disappear, even temporarily, challenges our sense of permanence and control. Yet fear quickly gives way to wonder. As darkness settles, crowds often fall silent. Some weep, others smile in disbelief. The experience becomes deeply personal and profoundly collective at the same time. Strangers stand together, united by a shadow that belongs to no nation, belief, or generation. Eclipses remind us that we are participants in a vast cosmic system, not its masters. They shrink human concerns and expand perspective. In those fleeting minutes, careers, conflicts, and routines feel distant, replaced by a quiet awareness of scale and time. When light begins to return, it does so gently, almost apologetically, leaving behind a sense of humility. The universe has not spoken in words, yet it has said enough. And then, as it always does, the shadow moves on. The sun reclaims the sky. The moon resumes its silent journey. Daylight returns, unchanged yet somehow transformed. What felt like an ending reveals itself as a continuation, a reminder that the universe is governed not by chaos, but by balance and rhythm. Eclipses teach us that darkness is not destruction, but transition. That alignment, though rare, is inevitable. And that even in a universe of immense scale, moments of perfect harmony can occur. For ancient civilizations, eclipses were messages from the gods. For modern science, they are gateways to understanding gravity, light, and time. For all of humanity, they remain something deeper, shared experiences that dissolve boundaries and awaken awe. In the end, an eclipse does not take the light away. It returns it, enriched with meaning. And as the sky brightens once more, we carry with us a quiet realization. We are small, the universe is vast, and for a brief moment, we were allowed to witness its shadowed beauty.